Question 4 on page 505 has us trying to do Hess's law for this reaction. This is the information that's given to us, and this is a difficult question, but it's possible to make it quite a bit more difficult if I reorder the reactions that are given to you. So I'd like to look at that question as a harder version where it's been reorganized. And I'll explain a little bit why it's harder. But essentially, whenever we're doing a Hess question, what we want to do is we want to focus on the discrete or the very specific reactants and products that are in each of the reactions. So if I look at this reaction, I want 3 moles of hydrogen, 1 mole of carbon monoxide react to make 1 mole of methane and 1 mole of hydrogen gas. We're going to try to find that amount of energy. So in this first reaction, I have a methane, and methane is probably going to draw your eye. It's a discrete chemical. It's the only chemical that's there. There's also oxygen, carbon dioxide, and water. But I would not choose to use oxygen to balance because oxygen's in all of these reactions. It's going to be a bit of a nightmare to try to balance. Carbon dioxide also shows up here and here. And so carbon dioxide might not actually be a great one to use to balance things out. So these ones highlighted in the yellow are maybe not the best choice to use to balance. I also have water in 2 different places. So those might not also be great to use to balance. But definitely from my first reaction, I want to have 1 methane in the products here. And so I take this reaction, and what I'm going to do is I want to get 1 methane in the product, so I'm going to reverse it. I'm going to take carbon dioxide gas plus 2 water vapor are going to make methane gas and 2 oxygen gas. And the enthalpy for this is going to be the same number. So it's going to be, because I didn't multiply by a fraction or a coefficient or anything, but it's going to now be positive 802.7 kilojoules instead of negative, because by reversing it, I change the sign. Now for my second reaction, I'm going to look, and when I look at this, I don't have carbon in this reaction. I do have oxygen, but oxygen's in all of these reactions, and carbon dioxide is also not in this reaction. So I'm not sure what I should do with this reaction. That's why this is actually a little bit harder than the textbook version, because carbon dioxide doesn't occur in this reaction, neither does carbon or oxygen. So what do I do with it? Well, the hint is if I can't find it as a discrete chemical, like my methane here, then I probably need to not use that reaction until later in the reaction. So I'm going to scooch down to this third reaction, and I want 3 hydrogens. I have 2 hydrogens here. So I want the hydrogens in the reactants, which is good, but I want a coefficient of 3 instead of 2. So I'm going to take this reaction, and I'm going to multiply it by 3 halves. So 3 halves times 2 gives me 3 hydrogen plus 3 half oxygen make 3 water vapor. So my enthalpy for this is going to still be the negative value, but I'm going to take the negative 483.6 and multiply by 3, divide by 2, and I'm going to end up with negative 725.4 kilojoules. And then I'm going to skip down to my next reaction. And in this next reaction, I've got carbon and oxygen. Those aren't great, but I do need carbon monoxide, but I only want 1 carbon monoxide in the reactant. So what I'm going to do is I'm going to take this reaction, and I'm going to reverse it to get it so the carbon monoxide's in the reactants, and I'm going to multiply by a half. So I'm going to end up getting carbon monoxide gas in the reactants, and I'm going to get my carbon, 1 carbon, because I multiplied by a half, so 2 times a half is 1, and then I'm going to get a half of an oxygen in my products. The enthalpy here, because I reversed it, becomes a positive value, and it's going to be half of that number, so it's 110.5 kilojoules. At this point, now the only reaction I have left is here, and I still am not sure why I need it, but I would notice that in my original reaction, I didn't have any carbon, right? But now I've got carbon, right? In this initial reaction, I never had carbon, but I've got carbon here. So what I'm going to do is I'm going to cancel that carbon out using this reaction. So if I take my carbon solid plus my oxygen gas makes carbon dioxide gas, my enthalpy here is going to just be the exact same, negative 393.5 kilojoules. And now my carbons cancel each other out. I subtract one carbon from the reactant and one from the product. I'm going to subtract one carbon dioxide from the reactants and one from the products. They cancel each other out. I've got 2 waters that are here, and I've got 3 waters here. So instead of just canceling, I subtract 2 from this side. That gets rid of them. And this becomes a 1. I have 1 water now instead of having 3 and 2. Right? I subtracted 2 from each side. If you didn't catch that, reverse it and take a look again. Now for my oxygens, I've got 3 half oxygen that is here, and I've got 1 oxygen here. And in the product side, I've got 2 oxygens, and I've got a half oxygen. So I've got 2 oxygen plus a half. So this is 3 halves plus 2 halves is a 1. So that equals 5 halves. And here, 2 oxygens is going to be 4 halves plus 1 half equals 5 halves. So all of my oxygens are going to cancel them out. This one goes, this one goes, this one goes, and this one goes. So what I'm left with at the end of my reaction is only the stuff I want. I've got 3 hydrogens plus 1 carbon dioxide makes a methane plus 1 water. And so I get the same net reaction that I was looking for in the first place. I've got 3 hydrogen gas plus 1 carbon monoxide gas makes 1 methane gas and 1 water vapor. And the enthalpy is the sum of these values. So I've got 802.7, positive 802.7, plus negative 725.4, plus 110.5, plus negative 393.5, and I come out with negative 205.7 kilojoules. Now to finish this, I want to make sure that it's not asking for molar enthalpy for something, but this is the net reaction for this. So this is a little bit trickier than the way it's laid out in the textbook, because this one that you use for bookkeeping, you need to skip over it until the end. In the textbook version, it was a little bit kinder, because what they did is they left that one until the end, and so you don't get tricked by it. But if you run into a reaction that none of the components of it are in this reaction that we're trying to prove, then you got to leave that till later. That's being used for bookkeeping.